Hello again, this is Mike, and this is about the 20th attempt of trying to get this video right. This is a walkthrough on some of the basic functions of the Geometer Sketchpad, or GSP, as well as a few examples of how you can use the GSP to help your students better understand geometry or algebra in the form of linear functions or calculus. So we've got two things going on. We've got your left-hand bar, and we've got all of the options up here. We're going to have to build a few things to use the stuff up top. So first is a dot command, as you can see. Then we have a circle command. You take the dot there, and you can pull out the radius. Let's go back to edit here. I don't necessarily like that line style, which now you can see the options, some of the display options there. So you have your circle, then you have your line segment, so you can build a segment in this way, or you can, when you press on this, you can build a ray in which the line will go completely down, or you can build a complete line like so. Some of these other things are a little bit more advanced. This right here is a text box, so you just drag it, click on it. This is a text box right there. This is a marker, so you can use the mark to mark congruent lines or draw random things. I'm not sure exactly how to use. You can also use it to make an angle point, and how do we do that? Oh, well, I guess that would be a way to do that, to mark congruent angles. Just so you know, my explanations might be a little bit choppy, but I've pretty much considered that you get the basic functions of the program, and I'm not really worried about my stuttering or stammering or mistalking. I've been stuttering and stammering from mistalking for a while now, and a perfect speech is just not going to happen. So we've got your text box, we've got your marker. Let's go back here. Let's build a few more segments. Let's make the color a little bit darker here. Make that blue a little bit darker. So we'll build a few more segments just so we can show you some ways to construct some things. So if we go back to the top here, this allows us to highlight certain items, to submit them for construction, measurements, etc. So we have construct, and you see all of these things that are unable to be clicked on because we have not clicked on any lines or points. So we're going to click on this line, we're going to click on this point, and you can see we can build a parallel line, a perpendicular line, circle, bicenter, and radius. So let's build a parallel line. That did not make any sense, actually. So let's undo construct parallel line. A better way to construct a parallel line would be to highlight this line here and, let's say, this point. And so if you construct, it will construct a parallel line on that point to this line. Much better. Let's move that point over a little bit. Don't want to confuse those. So you have a very good variety of things going on there. We're going to skip transform here, but let's go with measure. So we can measure the length, and that gives us a nice little equation here. So and it's automatically labeled some stuff for us. So now we have line AB equals 4.62 centimeters. This will come in handy later. So you find you can move it and the number will change. We also have a way to make some coordinates, stuff like that. We can calculate some things. So if we wanted to put well, apparently we can't really do anything there with what we actually have, but that's some random things there. We can go over this graph here. We can show the grid. We can plot a value on an axis, so we can do 0.1, 0.4. Oh, well, that's just axis X, so we can go back. Plot points would probably be a better idea if you're wanting to graph an XY. So we're going to have 3, 2, and we're going to finish there. When you have the grid up, it's important to note that this little dot here allows you to change the size of the grid. Notice that my point that I've plotted on the axis, 0.32, is still there. And if you have something that you want to build 15 units by 20 units or something, you can put that there, or whatever else you may want to do. So those are some of the basic functions, not very thorough of me here, but either way, we're going to sort of skip this one, or not skip it, but we're going to move on to some actual constructions. So one of the things you can do, a good example of where to start, is you want to show your students that a triangle has angles totaling 180 degrees. So you can build yourself a few segments in the shape of a triangle. And if you go back to your little arrow there, you can basically move them around however you want to. There's a way to make some of these things move proportionally to each other, which we can get into a bit later. However, so for now, let's show the labels. You're going to see that the GSP has automatically labeled these points in the order that I built them to build, triangle ABC. Alright, so in order to measure an angle, you're going to have to not just select the point the angle is on, but the order in which the angle is. So we're going to measure angle CAB, because angle A, if you try to measure angle A, obviously it could be the interior angle, and it could be the exterior angle, or if you had some other points skewing off of A, there could be actually a good amount of angles with A. So highlight the points in order, and that's important. You just have to make sure that A is in the middle. You're going to go to measure, angle, and then we're going to have angle CAB. Let's do that again. Angle ABC. And we're going to do that a third time. Angle BCA. And here is a good point to note that when you're highlighting things, you also have to unhighlight things. So since the angle ABC is highlighted over here, we have to unhighlight that. And just to be safe, I'm going to unhighlight everything here, and I'm going to go back to BCA. And we're going to measure angle. Now, let's say we want to label the angle measurement. Alright. Let's label it angle B. And let's see what happens here. We can change that to angle B. Label angle measurement. Angle A. can label angle measurement, angle C. So there you have the three angles in this triangle. And as you see, you move point C, and look at all of those numbers change. Well, there's an easy way to show your students that this will always be 180 degrees. Obviously, you could have them add up all of these three numbers a few different times, but it's kind of rigorous. So what we're going to do is we're going to go to number and we're going to go to calculate. And when we're in calculate, you can basically press the buttons angle A plus angle B plus angle C. And then you press OK, and then we have all of that. Let's label angle measurement again. Total angle measurement of ABC, which didn't end up being any shorter, but then you have 180 degrees, and then you can pull it out, and yet 180 degrees stays the same. If you want to prove to them that the whole function of the thing works, you can always calculate simply angle A plus angle B. Okay, and we're not really going to change anything there, and then you move it around, and it is fluctuating. We can go to 0, or almost 0. Anyway, that's a random triangle, so we're going to get rid of that. We're going to not save that, and we're going to build an isosceles triangle. And in order to build an isosceles triangle, there's probably a few ways to do it, but because we want the two sides to stay the same, what we're going to do is we're going to start with a circle. Because with a circle, as we know, each radius is equal. So we're going to do that. Then we're going to, so there's our circle. Now we're going to build two segments at any point on the radius. See how the dot highlights, and see how the circle highlights. So then we have two radius, or radii, however it's said. And then what you can do is you can build your third segment here. And there you have an isosceles triangle. Well, that's a little screwy, you might ask, and a little bit just doesn't look really nice. So you can highlight the circle here, double click, or however you do a double click on your particular Apple device, and you are going to hide circle. You can do the same thing for the point, and you can hide the point. And then, if you'll look at how the triangle can be moved, you can move these points anywhere, but you cannot change the distance of the radius. Now, had the circle been still up, we could probably change the size of the circle and move the entire isosceles triangle, but that's not really the point. So here's your isosceles triangle. You want to prove that the sides are equal, and you want to prove that the angles are equal. So what you can do is show label, show label, show label. So you've got your ABC, and just like before, we're going to measure the angles, but we're only going to measure AC and B, ACB and BCA. Oop, wrong thing here. Measure angle, and then ABC. We're not going to bother with relabeling anything or making it look fancy as we did before. Screw that up. Measure the angle, and 50.86. that's the way it is. No matter how we move this angle, the numbers are identical. So that's fun. So there's your isosceles triangle. And if you want to delete everything, you can actually just, press down on the mouse and drag a big square and then press delete, and that works in the applet. So let's say you want to build an equilateral triangle. Just going to do that real quickly. Here's a circle with a radius. Here on the radius, build yourself another circle. And then what you can do is you can construct points on the intersections. It's a little bit fancier way to do that. You can always drag a dot over and it'll highlight, and then obviously each distance between the points is a radius. And then there you go. That's an equilateral triangle, and you can do pretty much make everything larger or smaller with that construction. And you can use some of the same tools to show that these are always 60 degrees. Fun times. Don't save. Now, the last thing I'd like to show you guys is a good example of how to use the GSP's grid form in order to show some parabolas. Now this is a pre-built little thing. I'm sure someone else built it. I'm sure that you don't have to order it from anyone. But it was something that I had to deal with in a class. And so I just wanted to take it real quickly and show a little bit about how you can help the students to understand what's going on. So you've got your A, B, and C here, and you've got your grid. At least you've got your X and Y axis. Now, let's say we want to put in a new function. So this is a good way to do that. So, click on the A. A times X squared plus B times X plus C. So we've built our function here, ax squared plus bx plus c. Now, how do we exactly plot the function? Well, we go to plot the function, and there we have your parabola that we have built. Now, in a lot of math classes, the students are required to see, well, how does A affect the parabola? How does the value of B affect the parabola? And how does the value of C affect the parabola? And so then you come to the sliders here and you can drag it. You can realize that C affects the vertex of the parabola. B affects the y-intercept. As you can see, the y-intercept remains approximately 1, but not quite, because obviously, well, I guess it is 1 because C is in fact the vertex. So anyway, you could say, oh well, it's interesting to note that when B is negative 2.1, the parabola is way over there, and I'm pretty sure I'm way off and completely forgotten my rules on parabolas. So discount anything I said about what affects this, but here's where it gets interesting. Then you can see that when A is negative, the parabola faces down, and when A is positive, the parabola faces up. When B is negative, the vertex of the parabola is on the positive side of the axis there, positive side of the y-axis, and vice versa. C simply moves the parabola up or down, at least from what we can tell. So, other than me completely screwing up the formulas of parabolas and stumbling my way in speech, hopefully you've learned a little bit of something about the Geometer Sketchpad.